Hello, algebra students. We are studying adding and subtracting rational expressions in this lesson. In our textbook, this is section 8.5. Let's play a quick game of Are You Smarter Than a Fifth-ish Grader? And think about how we would add 3/4 plus 2/3 if we couldn't use our calculator, because this will really drive how we're going to be adding and subtracting rational expressions, which of course we won't be able to use a calculator for. So if you were told to add 3/4 and 2/3, hopefully you guys remember that you have to make the denominators match. The denominators are currently 4 and 3. They do not match, and we basically have to unreduce our fractions until the denominators match. And even though they're only off by one number, the way that you used to do this is would only use multiplication to change the denominators. Basically, what you would do is you would find the least common multiple of 4 and 3, the smallest number that both 4 and 3 multiply to, and that would be 12. 4 multiplies to 12, and so does 3. And so what you would do is you would multiply this one by the fraction 3 over 3, so that the denominator would be that least common multiple, 12. And you would multiply this one by 4 over 4, because that would make this denominator 12. And so over here, 3/4 would turn into 9/12, because you'd multiply the 3 and the 3 and the 3 and the 4. And then we would add 8/12. Essentially, like I said, what we've done is we've reverse reduced our fraction. Okay, 9/12 is an unreduced fraction. It's equivalent to 3/4. And 8/12 is also an unreduced fraction. If you simplified it, you would get 2/3. Once your denominators match, what you do is you add the numerators together and you get 17, but you keep the denominators the same. So you do not add or subtract the denominators. Once the denominator is the same, you keep the denominator and you only add the numerator, ending up with an answer of 17/12. It's very exciting. So with our lesson today, what we're going to be doing is we're going to be adding or subtracting these rational expressions. And remember, a rational expression is some sort of polynomial being divided by a polynomial. The process for this is going to first be to factor our denominator as much as we possibly can. If our denominator could be factored, we need to factor it. And then you are going to make the denominators match by multiplying the numerator and denominator by the same thing. It's not different than this. Even though they were only off by 1, it was not your guys' thought, more than likely, to be like, I'm going to add 1 here and I'm going to add 1 here. Okay, that's not a legal move. You can't make the match by adding or subtracting. You have to make the match by multiplying. Let's keep moving. Once the denominators match from this step, we're going to add or subtract the numerators. Remember, you're going to keep the denominator the exact same and just add the numerators, and then look to refactor. And if you can factor, look to see if there are any cancellations, any simplifications that can happen. So let's look at kind of some prep work for this. I don't care about what the numerators say right now. Let's say my two denominators that I wanted to add were x and x plus 2. Now, the thing that I'm trying to get you guys away from, that I've seen a ton of time in the past, is people just be like, okay, I'm going to add 2 and add 2. Now my denominators are both x plus 2. Remember, that is not allowed, okay? Remember, you have to use multiplication to make the match. So I cannot just do this plus 2 and plus 2. Instead, what I have to use is multiplication somehow. And what I'm actually going to multiply by would be x plus 2 over x plus 2. And then this one would need an x over an x. Now both denominators are x times x plus 2. That's going to be my least common multiple for a denominator. That's the denominator I'm looking for. What if these two things were in your denominators? One of them was 2x and one of them was x squared. Well, this one's got a 2 in it and this one doesn't. So I'm going to multiply by 2 over 2 here. And then now I'm really close, actually. 2x and 2x squared. This one just needs an additional x to be multiplied in the numerator and denominator. And now both of my denominators are 2x squared. Let's do one more of these. One denominator is x times x plus 2, and one of them is just x minus 2. This denominator over here is missing a plain x, like this one has, and it's also missing an x plus 2. If you multiply it in the denominator, you'd also have to multiply it in the numerator, whatever was up there. We don't know what it is in this problem, right? And now this one would just need an x minus 2 over x minus 2, and now both denominators have an x plus 2, and an x minus 2. Let's go ahead and take a look at how this is actually going to play out with some problems. Starting with an easy one, we have 7 over 2x plus 3 over 2x. My denominators already match. Nothing can be factored, neither the numerator nor the denominator. I'm going to try to make my denominators match. Well, they already do. So then I'm just going to add the numerators and get 10. And remember, the denominator stays the same, 10 over 2x. This actually can be simplified. The 10 over 2 is like a fraction. That will just simplify to 5 over 1, or 5 over x. 7 over 2x plus 3 over 2x is just 5 over x. Let's look at another example. A little bit more complicated because this one doesn't have matching denominators right away. We got 3 over 4x, and now this one's actually subtracting 1 over 7. I like to think of 4 and 7 and say, hey, what's my least common multiple of 4 and 7? And that would be 28. If I counted by 4s and I counted by 7s, the smallest number that they would both reach would be 28. So this one over here needs a 4 over 4 to multiply by. And this one is going to need a 7 over 7. The denominator on the left would be 28x, and the denominator on the right would just be 28. So this one also needs an x over x. And now both denominators would be 28x. On the left, this would be 21 over 28x, subtract. Multiplying 1 times 4 times x would be just 4x over 28x. Now I would subtract my numerators. In 21 minus 4x, these things are not like. One has an x and one does not, so they cannot be combined under subtraction or addition. And the denominator just stays the same. So 21 minus 4x over 28x. I would try to factor my numerator here. It doesn't have anything like in it. 21 and 4 don't. And so I can't simplify anything. Remember, there is implied parentheses around the numerator here, so I can't go in and cancel out just the x's or something. This is just the answer right here. 21 minus 4x over 28x. Next one, our denominator once again doesn't match. The common denominator that I'm going to be looking for would be 10x squared. This one is going to need a 5 over 5 to get there. And this one would need a 2x over 2x to get there. Right, that would make this denominator on the left 10x squared. My numerator, 2x times 12, would be 24x. And then on the right, 15 over 10x squared. I can add my numerators. Once again, they are not like. So I just get 24x plus 15 over 10x squared. And then from here, I'm going to refactor if I can, and they do have a 3 in common. So I can factor out that 3 and get 8x plus 5 over 10x squared. If 3 over 10 was a fraction that was simplifiable, I would simplify it, but it isn't, and so I can't do anything with that, and this is just going to be my final answer. Let's keep it moving. I'm going to first try and factor. I can factor actually the denominator here. This is our first problem where we've been able to factor our denominators. So 1 over 3x squared is going to stay for now, plus this is x over, I can factor out a 3x in this problem, and I would then have x minus 4. So from here, I'm going to try to make my denominators match because, of course, they do not. They both have this 3 out front, and so that part does match. This one has x squared, and this one just has x. So I'm going to multiply by x over x here. And then this one is missing the x minus 4. So I have to multiply by x minus 4 over x minus 4. Now this one says 3x squared times x minus 4. And the one on the right, once I multiply, kind of rearrange it in an order I want, it'll say also 3x squared times x minus 4. So my numerator up here, can distribute the 1 in, 1x minus 4 over 3x squared x minus 4. This is an adding problem. X squared over 3x squared x minus 4. I'm going to add my numerators, and I'm going to rearrange this in a good order. We like the x squared to go first, so it'll be x squared plus x minus 4 over 3x squared x minus 4. From here, I would try to factor my numerator. My numerator doesn't actually factor, unfortunately. There are no multiples of 4 that get you to positive 1. And although it's really common for students to cancel out like that, that is not a correct cancellation, because remember, there's implied parentheses around this whole thing. And so that's all one thing. It would have to perfectly match that to have something cancel. And that would just be our answer. Let's see here. We have at least one more. It looks like we have 2 more, and then we'll be done with this. So in this problem, both denominators can factor. The left one is going to be x plus 1 over factors into x plus 2 times x plus 2, or x plus 2 squared. That's the same, right? The idea is we list the factors of 4, looking for which ones could get you to 4, and that would be positive 2 and positive 2. And that's why I got those. Then we would factor this problem over here. We have a 6 in the numerator. That can be simplified, but our denominator here, that could be factored into x plus 2 and x minus 2. Remember, this is a perfect square. Subtract a perfect square. X, 2, add them, subtract them. That's how you'd factor that. So this one has a couple x plus 2's, and this one only has one x plus 2. So it's going to need an x plus 2 over x plus 2. And this one over here is going to need an x minus 2 over x minus 2. Because now both denominators have 2 x plus 2's and 1 x minus 2. So my denominator on this problem, on the left side, is going to be, I'm going to actually simplify it a little bit to x plus 2 squared times x minus 2. And I'm subtracting the exact same thing, x plus 2 squared, x minus 2. In order to add our numerators, we are not going to want these parentheses, and so I'm actually going to have to FOIL these statements or distribute these statements. The one on the left is going to become x squared minus x minus 2, and the one on the right is going to be 6x plus 12. Hopefully you guys caught that. I distributed the 6 to both, and I FOILed this statement. X squared outside times outside gave me minus 2x, and inside times inside gave me plus 1x, and then minus 2. Now I'm going to go ahead and subtract my numerators, and the denominators are going to stay the same. So my denominator is still going to be x plus 2 squared x minus 2. But my numerator, I'm going to subtract this. So I'm still going to have the x squared, but I'm subtracting a 6x. So negative x minus 6x is going to be negative 7x. And then negative 2 minus 12 would make negative 14. Now I'm going to try to factor this statement, the numerator. And the factors of 14 would just be 1 and 14 and 2 and 7. And none of these factors can get you to the middle term of negative 7. And so this is just my final answer. If something did factor, I would look to cancel it. But like I said, it didn't factor, so that's just my answer. In our last problem for the first part of this lecture, great opportunity for you guys to pause it here and see how you do. I'm going to start by factoring my denominators, and this denominator can be factored. So my numerator is still x plus 2, but my denominator I can factor out a 2. I'm going to be subtracting again, negative 2x minus 1. My denominator here can also factor, and this will factor into x minus 1 and x minus 3. Now I have to look to make my denominators the same, and I can tell right away. So remember, there's implied parentheses around there. It needs a 2 because this one's got a 2. So I'm going to multiply by 2 over 2 on the right. And then the one on the left is going to need an x minus 3 over x minus 3. And now both denominators are 2 x minus 1 and x minus 3. 2 x minus 1, x minus 3. Remember, you can rearrange that in the order that you would like. So in order to add or subtract my numerators, they are not going to be able to be in parentheses like this. So I'm going to have to FOIL, distribute, all that fun stuff. Distributing the 2 in gives me negative 4x minus 2. And FOILing this statement would give me x squared. Minus 3x and a plus 2x give me minus x minus 6. Now is the part where we are going to leave our denominators the same, 2x minus 1, x minus 3, but combine the numerators. I'm going to be really careful because it's subtraction. X squared doesn't have anything to combine it with. Here I have a negative x minus a negative 4x. Negative x minus negative 4x turns into negative x plus 4x or plus 3x. And then negative 6 minus negative 2 would be minus 4. I would look to factor my numerator, and it does actually factor in this problem. It would factor into x plus 4, x minus 1, because positive 4 and negative 1 multiply to this and add to 3. My denominator is still going to be 2x minus 1, x minus 3, but we do get the payoff of a simplification or a cancellation. My numerator is still going to have x plus 4. I could put parentheses around it, but it doesn't need it, times 2x minus 3, final answer. So this is part A for section 8.4. I'm going to put up a part B as well, which is going to be different examples than this type of question. If you guys have any questions, please do let me know.